Today we start what is called volumes of rotation. Volumes of rotation. So I have this document, and I believe I'm going to post this on the Google Classroom, so that it might be hard to read on the screen in front of you. You can just use the screen in front of you if it works, and if it doesn't work, then just download this document from the Google Classroom, and you can look at it. Basically, I have 5 questions here. 4 of these questions you can answer by thinking about, the real question is like, what do we mean when we say rotated about the x-axis? So I want you to try and think about that. At least try number 1 and 2, see what you come up with, and then check back with the videos and see what I do with it. Then try 3 and 4 and see what I do that, unless you want to be ambitious and try it all at once. So as usual, with my calculus introductory topics, the first 4 are things you can do. The 5th is something you can start thinking about, but we can't actually do it yet, because this number 5, this is what we're going to learn to do. All right, so take a moment, do at least 1 and 2 right now. All right, now let's go ahead and hopefully you've done those, so let's see what we can do. So in number 1, we have, let's draw the region R. All right, so our region R, should make a nice graph of it. We have the x-axis, the y-axis, the line x equals 4, and the line y equals 2, and we just have this nice rectangle, okay? It's a rectangle. So that's our region, and so the real point of these sort of opening questions is to think about what does it mean when we rotate a region in the plane around an axis. So we're going to rotate this around the x-axis, and you have to sort of be really thinking very 3D on this. So if I rotate this, what shape does it form? What did you think it formed? So I think it formed a cylinder, right? So in order drawing these, so you're now about to embark in the world of trying to draw things, which I'm not terribly good at, but I've learned some tricks for, and some of you are extraordinarily good at, and some of you are going to just really struggle with. So what I start with, if I want to rotate around the x-axis, I'll just mirror or reflect, across the x-axis. And then you got to remember that in perspective drawing, okay, a circle becomes an ellipse. So when I do perspective drawing, any circle is going to become an ellipse. So I want to draw the ellipse so that, it has horizontal tangent, vertical tangent, horizontal tangent. It's just a nice ellipse. All right, and then I want to try and match that ellipse over here, so like try to come out the same amount. Your drawings don't have to be perfect, but certainly mine won't be. And then as exampled by the fact that, we want the tangent to be vertical here and horizontal here. I did the bottom of this ellipse pretty good. The top looks a little flat right there. It's like somebody ran over this can. Okay, and then if you want to be super cool, you can add some like shading effects. Do some shading here. Try to make it look 3D. A little shading. This original shading I did of the region sort of throws off the shading perspective. Try to do that for the edge. All right, so what I got is a cylinder. All right, so this is a cylinder. So the answer to question number 1, what solid is formed? It is a cylinder. This is rotating around the x-axis. Okay, so now what about the volume of this cylinder? So, I know that the volume is pi r squared h. The radius is 2 and the height is 4. So that's pi times 4 times 4. It's 16 pi. All right, that's rotating about the x-axis. All right, but we could take that same region and rotate it about the y-axis. That's what number 2 is. So number 2, we're going to say, okay, I'm going to take that same initial region of 2 by 4. So here's 4, here's 2. This time I'm going to rotate it about the y-axis. So, what is it going to be the same volume? I mean, that's a question I would have right away. Will it have the same volume if I rotate around the x or the y-axis? So now I'm going to reflect across the y-axis. It looks like I haven't made it quite even, so it's going to be a little not very great drawing. And then I'm going to do my usual trick of putting I want to put a circle up here. So what I do is I make it look like an ellipse. This is a pretty broad ellipse because this is a large circle. You paint some happy little trees in there if you want. I notice I went down to like this line, so I'm going to go up to the same line. Lost it there. All right, so trying to keep these distances equal, and then I'll try to keep that same separation down here. All right. So I'm just using equal distances. I'm not really very good at drawing. A lot of you are going like, yeah, I can tell. All right, we'll do a little bit of cool shading here. Starts out dense and then gets lighter. And then like flat shading across here with some diagonals. And that looks like a fairly decent cylinder there. That looks like the water tank at Terrywell Park, right? Stand up on the mountain and throw rocks on it. Who's throwing rocks on top of the water tank at Terrywell Park? Not me, because that's prohibited. Look how it's still a cylinder. All right, so this one was rotated about the x-axis. This one is rotated about the y-axis. Right, so it was rotated this way. So I took that original shape and just rotated it around the y-axis. So that's the cylinder. Is the volume the same? Well, this time my volume is still pi r squared h. All right, totally didn't even pay attention to the lines on the paper. It's pretty sad. Okay, so that is equal to pi. Let's see, so now the radius is 4, so that's going to be 16, and the height is 2, so it's going to be 2, so 32 pi. Yeah, so since I was squaring the radius, and that the radius sort of affects the volume more. So this cylinder ends up having twice the volume of my original cylinder. Okay, so here's some of the essential basic ideas of what happens if I take a region described in the plane and rotate it about various axes. And we can find the volume using known volumes we have from geometry. And of course, that will also work in 3 and 4, but not 5, which is where the calculus comes in. All right, so I want you to, if you haven't done 3 and 4 yet, try 3 and 4, and I'm going to put those two in the next video.